The parabola C has equation y squared is 4ax, where a is constant. Okay. The par the parabola C has equation y squared is 4ax, where a is constant and a is positive. The point q, aq squared to aq, q is positive, lies on the parabola C has equation y squared is 4ax. The parabola C has equation y squared is 4ax, where a is a constant and a is positive. The parabola C has equation y squared is 4ax, where a is a constant and a is positive. The point q, aq squared, comma, 2aq, and q is also positive, lies on the parabola C. Show that an equation of the tangent to C at q is qy is x plus aq squared. Okay. Since the y square is 4ax is very typical parabola, we can draw this before we solving the problem. It is important to visualize the problem. So let's draw this parabola here. Y squared is 4ax here. Then if we can draw, since a is positive, then the graph looks like would be like this, and the focus of the parabola would be maybe here, though we don't know the exact a value, but we can approximate to just draw it. And this would be the directrix, since a is positive here. So this would be f, the focus of the parabola, and this would be the directrix, which is x is minus a here. Okay, and let me reread the problem A. Show that an equation of the tangent to C at q is qy is x plus aq squared. Okay. Qy is x plus aq squared. So how do we confirm this or prove this? The point Q lies on the parabola C. So we can estimate, though we don't know the exact coordinates of it, but we can draw it. If we assume that Q is on here, which is a q squared, comma, 2aq, then the tangent line would be like this. And A insists this equation would be qy is x plus a q squared. But since we know the parabola, since we know the equation, the form of the parabola here, y squared is 4ax. Since this is just a simple polynomial line, such type of mx plus b here. M is a slope and b is intercept here, y-intercept. So we can transform this equation like that form. So we can divide it by q, but make sure that q must not be a 0, but in the condition says the q is positive, so we can divide it by q, both sides. So divided by q here, 1 over qx plus aq here. So 1 over q must be the slope of this line, and aq must be the intercept, y-intercept. And how do we find the slope of the tangent of this line with our condition from here? We can simply using the derivatives of it. By chain rule, we can get the slope of this tangent dy squared. Okay. Dy squared dx is equal to d for ax dx. And the left side will be by chain rule is equal to dy squared dy times dy dx. And the right hand side is simply the 4a. That may be the constant, but so we can simplify this by 2y times dy dx over is equal to 4a. And we can divide it by 2y, but make sure in this case also y should not be 0. But we don't know yet, but we can we now simply assume that y is not the 0 here. So we can dy dx is 4a over 2y. Y is not 0. Assuming that. Okay. And since we're finding the slope at this point Q here, as you see, by using this equation, the q was a q squared 2aq. Alright, so the slope here would be 2a over 2aq, which is 1 over q. So now we found the slope of this line. And since the line must be a path through this point Q, so we can get the equation here. Y minus 2aq is equal to 1 over q times x minus aq squared. So we can multiply both sides by q here. To do what? To show that, to check that, to confirm that this equation here, which is qy is x plus aq squared. Okay, so we multiplied it. 2a q squared is like x minus a q squared, and this will be like this. Qy is equal to x minus a q squared plus 2a q squared is equal to x plus a q squared. And the problem is solved. This is the same. And the next questions. The problem B, the tangent to C at the point Q meets the x-axis at the point X, which is minus 1a over 4, 0, and meets the directrix of C at the point D. Find, in terms of A, the coordinates of D. Okay. It seems that it appears that there are many variables. So let's draw this before we calculate it. Okay. So the parabola was like this, which is y squared over 4ax. Since a is positive, the directrix must be here, and the focus of the parabola must be here. And let's draw the Q here. And the Q meets the x-axis at the point X here, okay. When we assume the Q is here, on here, and tangent to this line with another color here. Then the x-intercept would be here minus a over 4, 0, but graphically this doesn't make sense, because this would be minus a, and this should be much less. So the point x should be on the right side, should be right side of the directrix, but it's on the left side of it. So we have to uh, redraw the diagram to meet the condition. So how do we draw this to meet up the condition of the problem? That is, if we draw the tangent line like this way, and now it meets the condition that x is here, minus 1 a over 4 comma 0, and directrix okay, let's redraw the graph much bigger, entire graph much bigger. Okay, here, okay, let me redraw this here to here, this here, and the Q is here, Q. Okay, now it's much more better. And here minus a, and what's the d? This, then this would be d here. So d and x and q is here, and okay. Okay, the problem B requires find, in terms of A, the coordinates of D. Okay. So we want to express the coordinates of D in terms of A. Since the D meets the directrix of parabola C, we know the x coordinates of the D, which is minus A, and we don't know the y coordinates, but we can simply set as a k, and now we want to find this value. How do we find this? Using our conditions. Okay, since x is also on the line, the tangent line, the equation that we calculated above, so this we can substitute this value into our equation, because the y value of x-axis, well, the point x is 0, and we can simply find using this. So now I want to substitute by this equation. Qy is x plus aq squared. So 0 is equal to minus 1 over 4 a plus a q squared. So we can simplify this. Since a is not 0 again, we can divide it both sides by a. So 0 is minus 1 over 4 times q squared, and 1 over 4 is q squared. And here again, the q is a positive value, so q must be 1 over 2. Okay, so the slope was 1 over q, and so it must be 2. And what I'm trying to do is by using these relationship between the point D and point X, we can calculate and express the slope of this line with another expression like this. So D is minus a comma k, and x is minus 1a over 4 comma 0. So using these points, we can calculate the slope of it. So the slope here is y difference divided by x difference. So k minus 0 over minus a minus 1a over 4. Note that the direction must be always from one to another. So the slope would be k over minus a plus a over 4 is like minus k over minus 3a over 4. It's like minus 4k over 3a, and this is the slope. This must be slope, and the slope must be here too. The value, the 4k over 3a should be 2. So minus 4k is like 6a, and k is, we can divide it by minus 4, so it's 3 minus 3a over 2. So, and we're not just confirm this value, to check this value with arithmetically, but also we want to check in graphically, geometrically, by looking this graph. The k is negative, and the position on this diagram, it looks like it makes sense since D is here, the third quadrant in here, so k should be the negative value here. So we found the D is minus a comma minus 3a over 2. Okay, the problem B is solved. And next, given that the point F is the focus of the parabola C, find the area in terms of A of the triangle FXD, giving your answer in its simplest form, okay? Again, we can draw the condition in the problem to find a big picture of how we should approach. Okay, the F, the focus, must be here. Okay. That is A comma 0. And the problem C requires the area of the triangle FXD. Okay. FXD is like here. Find this area of the triangle FXD. FXD. How can you find this? It is very simple because it is the f and x is lies on the x-axis, so we can simply calculate the height, since the triangle, the area of the triangle is height times base times height also. So since the base is the difference, the distance between f and x, which would be which is the difference between these points, the difference between the x coordinates of these each point's value. So x is minus 1a over 4 times comma 0. So this would be base, and the distance from the x-axis to the y value here, the point D here, the distance from the point D to x-axis here would be the height. And we can simply, since this is the shortest, the vertical, the distance, so we can simply find by using the y-axis of the point D. So what was the k here, and k was minus 3a over 2. So this would be height. And this would be base. Oh, I did not divide it by 2, so I'm sorry here. So D was minus A over minus 3A over 2, and this is height of the triangle, and F A comma 0 here, and X minus 1A over 4. Of course, the absolute value of it, since this is the distance, is 5A over 4A, 5A over 4. So the height is the absolute value of minus 3A over 2. So this would be 3A over 2. So, okay. Okay, let me recap it. Okay, since the base is the distance between the x coordinates of these points f and x, so we can find the base is the absolute value of the difference between these x coordinates. So we can find it minus 1a over 4 here. So that must be 5a over 4 since a is positive. Always be careful when you want to find, whenever you find the value, the absolute value. And the height is the absolute value of 3a minus 3a over 2 is 3a over 2. So the area of the triangle FXD is 5a over 4 times 3a over 2 divided by 2. So that must be 15a squared over 16. All right, we solved all the problems in number 7. So if you have any questions or any new ideas about this problem and any other creative approaches to this problem, you can leave the comment below here, and next time I'll be back with the more problematic or more challenging problems with you. And thank you for watching this channel. Thank you.